everyone, welcome you all to the chemistry class. In this video, we are going to study the chapter acids, bases and salts. In this particular session, we are going to study the definitions of acids and bases, and we are also studying about the different types of acids and bases and about the indicators. Okay, let's get started. Yes, my dear students, in this chapter we are going to study the general properties of acids and bases, and also we will be studying about the chemical properties of acids and bases, like how do they react with each other and how do they react with metals, metal carbonates and all. And we will come across the pH scale. It is a scale which is used to measure the strength of acids or bases. Then we are going to study the importance of pH in everyday life. Then we are going to study salts. That is a product that is formed by the neutralization reaction between acid and bases. Yes. Then we will also study the preparation of some important compounds from common salts. Okay. But in this particular session, we are going to study about the definition of acids and bases and the different types of acids and bases and indicators. Okay. Let's get started. Yes, my dear students, you have heard these words, yes, acids and bases in the class 7th. Would you remember by hearing the words acids and bases, what you recall on this concept? Yes, we know that we have learned that how do acids taste? Yes, acids are sour in taste. This is all studied in class 7th, right? Yes, let me recall this concept. Acids are sour in taste. Suppose if I taste lemon, orange juice, tamarind, or unripe mango, how does it taste? It tastes like a sour. Why? Because it contains acid. So all the acids are sour in taste. Then what about the color change when they are dipped in the when litmus paper is dipped in the acidic solution? Acids turn blue litmus to red. Yes. Here litmus is an indicator which is used to test the presence of acid or base. If you take the litmus paper, that is blue litmus paper, and dip it in the acidic solution, what happens? It will turn to red color. This indicates that a given solution is an acidic solution. Okay. Then acids are good conductors of electricity. These are some general properties that you have studied in class 7th, right? These are good conductors of electricity. Then acids produces hydrogen ions in aqueous solution. Yes, acids produces hydrogen ions in aqueous solution. When acids are dissolved in water, they furnish H plus ions, which give them the characteristic properties of acids. Okay. Then what you have learnt about bases in class 7th? They are bitter in taste. Bases are bitter in taste. Suppose if you taste the toothpaste, okay, how does it taste? It tastes very bitter, yes, because it contains base. They are bitter in taste and they turn red litmus to blue color. Yes, this is how we can test the base by using litmus. Okay. Then these are also good conductors of electricity. Then these produces means as bases produces OH minus ions, that is hydroxide ions in aqueous solution. Okay. The characteristic properties of bases are due to this OH minus ion, that is hydroxide ions. So what is the reason that they conduct electricity? It is because due to this reason. When they are dissolved in water, they form ions which is responsible for conduction of electricity. Okay. Then can you give example of acids? Yes. Citric acid, which is a naturally occurring acid. Citric acid, lactic acid, then hydrochloric acid, etc. These are example of acids. Then what about bases? Magnesium hydroxide, sodium hydroxide. These are examples of bases. Have you seen the soap that you use daily for bathing purposes? It contains base because of which it is slippery to touch. Yes, bases are also, they are slippery to touch. Why? Because they contain bases. Soaps are slippery to touch. Why? Because they contain bases. Slippery to touch. These are some general properties of acids and bases that you have also seen in the class 7th. Okay. Then how do we define acids? So acids are the substances which furnish H plus ions in aqueous solution. Okay. These are substances which furnish or which produces H plus ions, that is hydrogen ions in aqueous solution. As they produce hydrogen ions, they must contain hydrogen in their molecule. Okay. For example, HCl is hydrochloric acid. It contains hydrogen. HCl, it is a hydrochloric acid. It produces H plus ions in aqueous solution. Therefore, it is an acid. Then H2SO4. H2SO4 is also acid as it furnishes H plus ions in aqueous solution. HNO3, nitric acid. This is acetic acid. It also produces H plus ions in water. These are some examples of acids. Okay, this is hydrochloric acid, sulfuric acid, nitric acid, acetic acid. So when these are dissolved in water, when they form aqueous solution, they furnish H plus ions. Like when HCl gas is dissolved in water, it forms H plus ion, Cl minus ion. The characteristic property of acids is due to the formation of H plus ions. Okay. Then let us study the classification of acids. Acids are classified into different categories based on sources, concentration, strength, etc. Based on sources, they are classified into organic acids and inorganic acids. The acids which are produced from plants and animals, they are called as organic acids. Okay. The acids which are obtained from plants and animals, they are called as organic acids. There are many examples that you can see in your daily life also, like examples, citric acid. Where do you find citric acid? Yes, obviously it is found in citrus fruits. Citric acid, which is found in citrus fruits like oranges, lemon. Then lactic acid, it is found in curd. Then oxalic acid, it is found in tomatoes. Tartaric acid, it is found in tamarind and unripe mangoes. These are some organic acids from plant extract. Okay. Then what about animal extracts? That is in ant sting, there is a presence of methanoic acid. Yes, methanoic acid or bee sting. Then in nettle leaves, there are hair-like structures which contains nettle leaves. They also contains methanoic acid. Yes, nettle leaves. It is found in nettle leaves. Yes, these are some examples of organic acids which are obtained from plants and animals. Okay. Then what about inorganic acids? These are acids which are obtained from minerals. Okay. These are acids obtained from minerals. Yes, can you give examples for inorganic acids? Yes, we have studied right now, that is hydrochloric acid, what we call HCl, nitric acid, that is HNO3, and sulfuric acid. These all are inorganic acids. Organic acids are weak acids. These are weak acids. As they do not completely ionize in aqueous solution to produce H plus ions. Suppose if there are 100 molecules of citric acid, then all of them will not give H plus ions. Only 5 to 10 molecules will give H plus ions in this way. Whereas inorganic acids are, these are strong acids, as they ionize completely in water to form H plus ions. Okay. These are strong acids. Next, based on the strength of an acid, they are divided into strong acid and weak acid. If the acid ionizes completely in water, that is in aqueous solution, it is called as strong acid. It is called strong acid. Just now we have studied hydrochloric acid, sulfuric acid, nitric acid. These are all strong acids as they completely ionize in water to form H plus ions. Okay. Examples: hydrochloric acid, sulfuric acid, nitric acid, etc. These are all strong acids. Okay. Then weak acids are those, means if the acid do not ionize completely in aqueous solution, it is called as weak acid. For example, acetic acid, CH3COOH, it is acetic acid. It will not completely ionize in water to form H plus ions. It will remain in the form of molecules also. If you take the solution of acetic acid in water, there are present there the molecules are also present because it is not completely ionized. It also remains in the form of molecules. Whereas if you take hydrochloric acid in water, it ionizes completely. So whatever the solution consists of ions only. Okay, it doesn't consist of any molecules there because it has completely ionized. Okay, and also formic acid, HCOOH, it is also a weak acid. It will not completely ionize. Okay, there are presence of molecules also. Formic acid molecules are also present in the solution as it doesn't ionize completely. Okay, it is formic acid. Then based on concentration of the acid, it is divided into concentrated acid and dilute acid. Okay, it is dependent on the amount of acid that is dissolved in the solution. Okay, if an acid has relatively high percentage of acid dissolved in it in the aqueous solution, then it is called as a concentrated acid. Okay, then it is called concentrated acid. If I take sulfuric acid solution and it consists of large amount of sulfuric acid, okay, then it is called as concentrated acid. It is a relative term. Okay. Then what about dilute acid? If an acid has relatively low percentage of acid dissolved in the aqueous solution, acid dissolved in aqueous solution, then it is called as a dilute acid. Dilute acid. Okay, if I take an acid, if I dissolve some 10 gram of acid in it, okay, if I want to dilute the acid, what I can do, I can add more amount of water to it so that the amount of acid, that is percentage of acid in it, gets reduced. Okay, these two are relative terms. If the acid consists of relatively high percentage of acid in the aqueous solution, then it is called as concentrated acid. And if it consists of low percentage of acid in the aqueous solution, then it is called as dilute acid. Okay. Then these are the classification of acid based on strength, concentration and sources. Now let us understand some of the uses of acids. Okay. As we have already studied that acids are present in many food that we eat, like in vegetables like lemon, and in fruits like citrus fruits like oranges, there is a presence of acid, that is citric acid. And where we use the acids in general, let us see. Vinegar is a diluted acetic acid. It is used in the preservation of food. Okay, and also it enhances the taste of food. When you add vinegar to the food, you might have seen that fast food restaurants, usually vinegar is added in order to enhance the taste of the food. This is a one of the uses. Then hydrochloric acid, it is used in the industrial level for cleaning the deposits of boilers. Suppose in the boilers there is a deposition of any material, for as it is used for a longer duration of time, then in order to clean it, we can wash it with the hydrochloric acid. Okay, and also it is used in the cleansing of sink also. Then nitric acid, it is used in the manufacture of fertilizers and in cleaning gold and silver ornaments. Then sulfuric acid is used in cells and car batteries. Then salicylic acid is a type of acid. It is used in the preparation of aspirin as it has anti-inflammatory properties. Okay, then carbonic acids which you usually see in the soft drinks. Okay, these are all some of the uses of acids. Now let us see the concept about bases. That is, how do we define bases? Bases are the compounds which produces hydroxide ions in aqueous solution. Okay. These are compounds which furnish hydroxide ions in aqueous solution. Hydroxide ions. The characteristic properties of base are due to the presence of these hydroxide ions. Yes, we know different examples like magnesium hydroxide, sodium hydroxide, NaOH. It is sodium hydroxide. When it is dissolved in water, what happens? It forms sodium cations and hydroxide anions. Then magnesium hydroxide, etc. These are some examples of bases. Okay, now let us see the classification of bases based on strength. We have already discussed about the classification of acids based on their strength. Yes, what do we mean by strong acid and weak acid? We have come to know. Now let us define strong base. The base which dissociate completely in water to form hydroxide ions is called as strong base. The base which dissociates completely in aqueous solution to furnish hydroxide ions to furnish hydroxide ions. They are called as strong base. Okay, is called strong base. For example, potassium hydroxide, sodium hydroxide, these are strong bases. Okay. Example, sodium hydroxide, potassium hydroxide, these are strong bases. Then how do we define weak base? The base which do not completely ionize in aqueous solution. Completely ionize to form hydroxide ions in aqueous solution. Okay, they are called as weak bases. Is called weak base. So the example for weak base is ammonium hydroxide. It is a weak base. It will not ionize completely in water to form hydroxide ions. Okay, this is about a strong base and weak base. Then let us study one more classification of base, which is based on concentration. We call concentrated base as a base which has relatively a high percentage of base present in aqueous solution. Okay, the base which has relatively high percentage of base present in aqueous solution is called concentrated base. Suppose the base consists of large amount of base than water, then we call it as concentrated base. If the amount of water is more present in base, means we have diluted it by adding more and more water, then that base is called as diluted base. If the base which has relatively low percentage of base dissolved in aqueous solution, there is a presence of more amount of water there, so we call it as dilute base, same as dilute acid that we have seen earlier. Okay, relatively low percentage of base in aqueous solution is called dilute base. Okay, this is about concentrated and dilute base. Okay, then one more thing you have to remember here is all the bases are not soluble in water. Okay. Only some bases are soluble in water. The bases which are soluble in water are called as alkalis. What are alkalis? The bases which are soluble in water are called alkalis. Okay. For example, sodium hydroxide, potassium hydroxide, these are alkalis. Okay, then one thing you have to note that all the alkalis are bases, but all the bases are not alkalis. Okay, all the alkalis are bases, but not all the bases are alkalis. Why? Because as I have earlierly said that all the bases are not soluble in water. Only those bases which are soluble in water like sodium hydroxide, potassium hydroxide, they are called as alkalis. So these are also bases. Yes, alkalis are also bases, but not all bases are soluble in water. So they are not always alkalis. Okay. Next. Next, we have seen in the beginning of the chapter that we have find out the identity of a substance, that is whether it is a base or an acid, by using the indicator. So what are indicators then? Indicators are the substances which indicate the presence of acid or base in a solution. Okay. We cannot always taste all the substances. Yes, we know that acids are sour in taste and bases are bitter in taste. But is it possible to taste all the chemicals? No. As acids and bases are corrosive in nature, we cannot taste the substances. So we should have some scale. We should have some indicator which will show the presence of acid or base. So these are the substances which show the presence of acids or bases. We have two types of indicators, that is natural indicators and synthetic indicators. Let us see the examples for natural indicators. As we have seen in the beginning of the chapter that litmus, it is a natural indicator. How it is obtained? It is obtained from the lichen plant. It is extracted from lichen plant belonging to the Thallophyta family. Okay, it is a purple color dye, actually purple color. Okay, it is available in the form of solution nowadays, and also it is available in the form of strips. We prepare two different types of solutions from two different varieties of lichen, that is red litmus and blue litmus. Okay, they are available in the form of solution also, and we can also prepare strips from the litmus. Okay, what happens when we check the acidity of a substance with red litmus? Suppose if you check the acidity or basicity of a substance with red litmus, the acid will show no color change. Okay, means the litmus will show no color change in acidic medium. Okay, no color change. Suppose when red litmus is added to base, it will change to blue color. It will change to blue color. What about blue litmus then? When blue litmus paper is dipped in acidic solution, it will change to red color, red color. And when it is added to base solution, it will show no color change. This is how we will test the identity of a substance, whether it is a base or an acid, by using litmus. We have two litmus, that is red litmus and blue litmus, which is prepared from two different varieties of lichen. Then we have few more natural indicators like turmeric. We all know that it is in bright yellow color. It is a natural indicator. How does it shows the color change? In acidic medium, it shows no color change in acidic medium. Okay. Whereas when it is added to basic media, it will show the color change to red. It changes to red color in basic medium or in basic solution. Okay. This is how turmeric can be used to indicate the presence of acid or base. You have to remember the color change. It will change to red color in basic solution. It will show no color change in acidic medium. Then we have different few more different natural indicators like examples, colored petals of hydrangea plant. Okay, flowers, hydrangea, then petunia and geranium. These are few more natural indicators. Colored petals of hydrangea, petunia and geranium. This is all about natural indicators. Okay. These are few more natural indicators. As it is mentioned in your NCERT textbook, you should remember these. Okay. Natural indicators. Then what about synthetic indicators? As the name itself indicates, they are prepared in the laboratories. Okay. Mainly there are two indicators which are oftenly used. That is Phenolphthalein, it is colorless in color. It is colorless. It is colorless. An alcoholic solution of phenolphthalein is used as an indicator. Okay. It is basically colorless and it shows pink color in basic medium. It shows color change, that is pink color in basic medium. This is about phenolphthalein. Okay. And it is colorless in acidic medium. Suppose you add phenolphthalein to acidic medium, it shows no color change and it turns to pink color in basic medium. Okay. This is one synthetic indicator. Then there is one more synthetic indicator which is often used, that is methyl orange. As name itself suggests, it is orange in color. Okay. Phenolphthalein is colorless. Methyl orange, which is basically orange in color, it turns to red orange in acidic medium, in acidic solution, whereas when it is added to basic solution, it turns to pale yellow. It turns to pale yellow in basic solution. So this is how the indicators indicate the presence of acids and bases by change in their color. So how do you define indicators then? Indicators are the substances which indicate the presence of acids or base by change in color. This indicates the presence of acids or bases by showing change in color. By showing change in color. Okay, next. Now, there are special types of indicators called as olfactory indicators. Earlier, we have studied that indicators show color change in when they come in contact with acidic or basic media. But these indicators are special so that they show the presence of acids or bases not by change in color but by change in their smell. Okay. The indicators which shows the presence of acids or bases by showing change in their smell. Okay, these olfactory indicators have their characteristic smell, but when they come in contact with either acids or bases, they change their smell. This is how we can identify a given substance is an acid or base by olfactory indicators. What we need to do? We need to observe the change in odor or change in smell. Can we give examples for that? Yes. Examples: clove oil, vanilla extract, onions. These are some examples for olfactory indicators. Okay. How do they show the change in their smell? Suppose when you keep the vanilla extract in acid medium, it retains its smell. Okay. It retains pleasant smell. Vanilla extract is having the pleasant smell. It retains its smell in acid medium. But when it is kept in basic medium, it will lose its smell or lose its odor. This is how they will show the presence of acids or bases. Okay. A very interesting activity is given in your NCERT textbook about the preparation of onion peel indicator as an olfactory indicator. How can you prepare it? Even you can do it in your home also. Okay. You have to take small pieces of onion in a plastic bag and keep small pieces of clean cloth, small cloth along with onion pieces, onion pieces. Okay, and keep this plastic bag in fridge and keep it overnight. Okay, keep the bag in the fridge overnight. Then what you need to do next is you have to take out those cloth pieces. Okay, those cloth pieces have gained the smell of onions. Okay, as it has its own characteristic smell, those pieces of cloth has the smell of onion. Then how do we use this as olfactory indicator is, we have to check it for acid and base. Okay, if you check for acid, if you dip the piece of small cloth in acidic solution, the smell of the cloth retained its characteristic smell. Okay, it retains smell. If you dip the cloth that is kept overnight with along with onion peels and you dip it in the acidic solution, then it will show no odor change, means it retains smell. Okay, suppose if you dip the same another one cloth that is kept along with onion pieces in basic medium or in basic solution, what happens? You can easily feel that it loses smell. Okay, whatever the characteristic smell of onion was there before, of dipping it into the basic solution, it has lost its smell. This shows that the given solution is of a base. If it retains the smell, then it is acid. If it loses the smell, then it is basic solution. This is how we will see the order change, means we will feel the order change by using olfactory indicators. These are special type of indicators in order to check whether a given solution is of acid or base by change in order. Okay, this is how we will observe the changes. Let us discuss one interesting question here, which is a in-text question. You have been provided with three test tubes. One of them contains distilled water and the other two contains an acidic solution and basic solution respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? Okay. So now I have only the red litmus paper. What I need to do is dip the red litmus separately in all the solutions. Okay. In all test tubes separately, means you have to take different strips of red litmus only for testing in all test tubes. We know that in basic media, the color change that is observed is, that is the color change is red to blue. Let me write it separately so that you can understand it easily. The red litmus is dipped in basic media, it turns to blue color in basic media. Suppose you dip the red litmus in acidic media, it shows no color change. Okay. Then what is the color of litmus in neutral solution? It is purple color. Okay. By this, by this technique, we can understand which of the given solution is acid, base or neutral. Okay. The test tube in which color of red litmus turns to blue indicates that solution is base, because red litmus turns to blue in basic solution. So we have find out one of the test tube has contained base. Then the test tube in which color of red litmus turns to purple indicates that the test tube contains water, because water is neutral in nature. Okay, the distilled water is neutral in nature, that is neutral. Then we have one more test tube that contains acid. How does the color change occurs there? The test tube in which color of red litmus remains same, then the solution is acidic. This is how we will understand the color change and identify the substance which is acid or base. Let me repeat it again. We have given only the red litmus paper and we are given three test tubes containing acid, base and neutral. What we have to do is we have to dip the red litmus paper separately in three test tubes. If it is neutral, the color of red litmus will change to purple, as the color of litmus is purple in neutral solutions. Suppose if it is a basic solution, then it will change to blue color. If it is an acidic solution, then it will show no color change. Okay, this is how we will identify the substances or solutions, whether they are acids or bases, by using litmus paper. Okay. Okay, in this today's session, we have discussed what are acids, bases, and classification of acids and bases, and we have also studied about the indicators, types of indicators. Okay, this is all about the first session. Next, let us consider the chemical properties of acids and bases in the next session. Okay.